Hi guys, not here today, or Friday for that matter. So this is as good as it gets, is my voice on your video. You should have watched the video already from Learn Zillion or whatever it's called, that had the translations, rotations, and reflections. If you haven't watched that, make sure you have the sub go back and watch that first. So now you're on page 14 of your packet. This is what the picture looks like. You should all have a piece or two of patty paper. If you don't do that, have that, and a ruler. One of these, actually a protractor would be better. Get that now, press pause and do that. Okay, so now that you have, let's go ahead and do what it's asking me to do. I'm going to do it quickly for you because the video will be limited. Go ahead and put your patty paper over the center here, the origin. Put your dot here at the origin, and then put a dot on A, B, and C, and then quickly but neatly connect them without moving the patty paper, A to B, B to C, and A to C. And now the reason we have our patty paper is this. The origin here, don't let it move. Kind of use your pencil as like an anchor point, like as a pivot, and then they want you to slide it around and see or prove that all of these are the same image, just being rotated around a point at the center, which in this case happens to be the origin. And it's true, it does that all over the place. Goes all the way around, and every one of them should match up. Okay? So, what we're doing here then is going, well, let's take a look at this picture and see how many triangles we actually have. And it's talking about 360 degrees in one full rotation. You know that. A circle is 360 degrees. Well, how many are there total? How many of these triangles? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, what's 360 divided by 12 triangles? Well, what's 36 divided by 12? And clearly that's 30, right? And why is that cool or relevant? Well, here's what I'd like to do. Everybody use your straight edge here to draw this line from the origin to point C here. Now, this rotation here would mean this is C prime right here, this little dot here, right? It's just rotate. Now I want you to do that as well. Draw a line, nice straight line from the origin to point C. Now, just watch and then you'll see what I'm about to do. So now if you remember how to use a protractor, this center hole here is where you put the center of something you want to measure an angle to. So if I put that on the origin, and you can see how this little line right here is about to line up there with the bottom line of the protractor. That is the one line that we have for this triangle, to this point. Now check out point C here. If I extend this out, where does it look like it's pointing to? Doesn't it actually look like it's pointing right to 30? And that's actually true, because each rotation of this triangle is 30 degrees. And we just kind of showed that by measuring it. Pretty cool. Okay, let's quickly turn the page, go to the next one. In the previous picture, we basically did the same picture, except they only did rotations of 90 degrees. So you can't use the same patty paper, unfortunately, because if I show you the picture's wrong, it's a little bit bigger, different. So if I do this, if I move my origin to here, now ignore that one. Now if I stick my pencil there and rotate it, you can see that I just turned it 90 degrees. The patty paper was this way, now it is 90 degrees, and it lines up with that. And it's a little bit bigger just because the image. But that's a 90 degree rotation, another 90 degree rotation, another 90 degree rotation, and back to where we started. And you can actually go the other direction too. So verify using tracing paper that the descriptions of the rotations are accurate. And we did that. This is 90 degrees counterclockwise. This is counterclockwise. This is 90 degrees clockwise. And again, depending on which direction you go, it can be 90 degrees clockwise, or if you went to other direction, it'd be 270 degrees counterclockwise. So the direction matters. The rotation from figure 1 to 4 has been described as a 90 degree counterclockwise rotation. So figure 1 to 4 is 90 degrees counterclockwise. True. How would you describe this rotation clockwise? Well, the answer is right there. It's 270 degrees clockwise, and I'll abbreviate that CW. I'm going to have you guys press pause here, and I want you guys to do the slopes of all 6 of these line segments. Press play when you've had a chance to do all 6 of the slopes. For example, AB, what's the rise and run there? 2/3 for AB. A prime, B prime. This is in figure 1 to figure 2, so that's over here, right? So A prime, B prime. So this was 2/3. Now this is negative. See what's going downhill? Negative 1, 2, 3, positive 2. So negative 3 over 2. Notice anything about these? BC, down to right 2, down to right 2, simplifies to negative 1. B prime, C prime here, up 2, right 2. And then AC. Remember what kind of a slope that is. If it's a horizontal line, hopefully you know that that slope is 0. Then that sucker's been rotated 90 degrees, and now that is undefined. Okay, the one I really want you to focus on is this. Anything that's rotated 90 degrees from it, when this shape's rotated, look at these slopes and see if you can kind of figure out some pattern here. You notice that these are switched. One's positive, one's negative. Isn't that really called the opposite reciprocal? Does anybody remember the name of that when lines have opposite reciprocal slopes? Hopefully you do. It starts with the letter P. This line here and this line here, this line here, this line here are perpendicular to each other, guys, and that's the answer to this. So the relationship between 90-degree rotation slopes is that they are perpendicular. They are opposite reciprocals because they're perpendicular. Okay. Number 9, describe what happens in a 180-degree rotation of a figure. What is the relationship between the corresponding segments? Okay, so that guy went all the way over here. What is the relationship of the corresponding segments? So AC is basically the same segment as AC. Did the slopes stay the same here? And hopefully you'd say yes, but now let's check the other ones. From A to B is 2/3. What about from B to A? Do you notice that it's still 2/3? So, 180-degree rotation, even though the figure turns upside down, the slopes stay the same. Okay. Go ahead and turn the page here. Alright, center of rotation is the origin. In other words, if we had our patty paper right here, which I want you to get in the habit of using, put your dot there for your origin, put 1, 2, 3, 4 points here for this parallelogram. See what I just did? I moved the paper, so don't draw it unless the paper has been re-centered on the origin and where your 4 points are. Nice and neat. Otherwise you won't get an accurate enough drawing. There you go. Okay. So now if I stick my pencil right there and I rotate it 90 degrees, you see that it's a 90-degree rotation. Let's answer the questions based on that. Determine the angle of rotation. It's 90 degrees. But which way did I go? I went down and to the left. Is that clockwise or counterclockwise? Well, that is CW, counterclockwise. The slope of EH is -2. Let's prove that. EH is here. Down to right 1, right? Down to right 1, which is -2. It says determine the slope of EH without doing any calculations. Well, can't I just count it? But we want to go back to this, right? The opposite reciprocal of this slope, it must be this slope because it's a 90-degree rotation. This line and this line are perpendicular to each other. And what's the opposite reciprocal of -2 is? Positive 1/2. Check it out. 1/2. I'm going to prove it to you just with your eyeballs. Take this drawing right here, take this line and extend it with your ruler. Now line it up as carefully as you can and extend it with your ruler. Does that look like they hit, like this line and this line hit at a 90-degree angle? It does to me. And we've just verified it with the slopes. Okay, number 11. For the following rotation, the center of rotation is in the origin again. So now this one kind of tricky for kids at first. Go ahead and do your patty paper, trace this, and then I want you to rotate it until you get to here. Press pause and do that, and then I want you to answer the questions. Did you say it was a 180-degree rotation? If you did, you're correct. Now, it could be 180 degrees either clockwise or counterclockwise, depending on which direction you went. It's not 90, because 90 would have ended up being a vertical line here, which is perpendicular to this horizontal line. The slope in PQ and PQ prime, P prime, Q prime, are the same. Why? Because when you turn a horizontal line upside down, you've kind of done the opposite reciprocal of this slope would be a vertical line, but what's the opposite reciprocal of a vertical line is back to a horizontal line. So the slopes are both 0, and the reason this happens is because when you are perpendicular to a perpendicular, you're kind of going back to where you started. Okay, I'm down to a few minutes left on this video, so I'm going to ask you guys to do a little bit on your own. Go ahead and read the next question and see what you can glean from. Okay, here's what I'm doing right now. I'm putting my origin there, I'm putting my 2 points right there. I'm going to connect them with my ruler quickly. And then it's asking us to rotate it 90 degrees counterclockwise. So, keeping your pencil tight on the page, 90 degrees. And just look at the patty paper. If I go 90 degrees, it should look like that. And check it out. Doesn't it hit the circle right here and right here? Like 2 to the left and 2 above. Like 2 to the left and 2 above. Right? Let me do that again. Put my pencil there. 2 to the left on top and 2 above on that one. So it's 2 to the left and that one. And there is a 90-degree counterclockwise rotation. If that's the case, shouldn't these be perpendicular to each other? And let's just verify that. I'm going to skip this. So the slope of this guy is down 1, 2, 3, 4, right? 1, 2, 3, 4, 5, 6. So negative 4 over 6 is equal to negative 2/3. Well, what should this then be? If it's perpendicular to this, it should be the opposite reciprocal of that. And let's verify that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 6 over 4 is equal to 3 over 2. 3 over 2 and negative 2/3, or even those two are opposite reciprocals, so they're perpendicular. Okay, I'd like you guys to do all 4 on the last page, all the rest of the pages, problems together on the last page on 17, and then work together on those, and then after you guys have worked on those for maybe 5 or 6 minutes, maybe 10 minutes, go ahead and check the answers, which is on the next page that I'm going to reveal here. So I'm going to ask the sub to press pause now, let you guys work on the last page together, and then go ahead and verify your answers after you've had a few minutes to work this, and then ask for any clarification or help. So do that now, and then check your answers. Okay, here's the big reveal. Let's see if you did everything right. 90 degrees counterclockwise, that goes down like this, so it looks kind of like a ship, a little boat. That's what your image should look like. Number 14, 90 degrees counterclockwise. So again, here was your original image. If you go counterclockwise, you're going down to the left, and it turns everything that was horizontal vertical and vice versa. Hopefully you read that it was 180 degrees, so if you use your patty paper here, you rotated it either clockwise or counterclockwise, you're still going to end up here, down in this 4th quadrant for your triangle. So it's kind of way down here. Remember, the angles, everything are going to be the same. And the last one here, you started down here in quadrant number 3, and you rotated it 180 degrees clockwise. It ended up here in quadrant number 1. So check your work, make sure everything's verified, ask for help if you need it. Okay, I'm down to about 15-20 seconds here. So I'm just going to give you the answers to these. Ask for help if you need it. The slopes of corresponding segments may change in what kind of transformation? Well, if you keep if the slopes are going to change, that means it could be a reflection, like from last night's homework, and a rotation. So if you rotate stuff like 90 degrees, you're going to get opposite reciprocal slopes. And if you reflect it, something that was going uphill is going to be going downhill. Number 18, the angles in the image and pre-image stay the same. That's actually in a translation, a reflection, and rotation. In other words, the image isn't growing. And lastly, translation, reflection, and rotation for that one. I am out of time. I'm sure you guys are going to figure this out. Good luck.